All right, good morning and welcome to Master Talker online class. Please, if today is your first day of watching our video, please click the subscribe button, okay, and turn the notification bell so that anytime we drop a video like this, uh, YouTube will notify you. And this is our first video on organic chemistry. So tell us what you think about that, if we should continue or not, okay? Okay, now let's go into the main deal. Organic chemistry is simply the chemistry of carbon compounds, okay? Chemistry of carbon compounds, which means that organic compounds are called carbon compounds. Okay, although there are exceptions to that, there are some carbon compounds that are not organic chemistry. Okay, listen, organic chemistry is the chemistry of carbon compounds, but not all carbon compounds are organic chemistry. Okay, so you need to know that every organic chemistry is a carbon compound, but it's not. In fact, every organic chemistry, every organic compound is a carbon compound. Every You need to know that, very important. Every organic compound is a carbon compound, but not all carbon compounds are organic compounds. Please note that. Okay, so let me tell you the exceptions to some carbon compounds that are not organic compound. For example, CO, that is carbon monoxide, CO2, carbon dioxide. Another one is metallic triosocarbonate 4. And metallic triosocarbonate 4, example of that can be Na2CO3, that is sodium triosocarbonate 4. You can have potassium triosocarbonate 4. These are exception to uh, carbon compounds that are not, or these are organic, what am I saying? These are carbon compounds that are not organic compound. Okay, another one can be triosocarbonate 4, that is hydrogen triosocarbonate 4, hydrogen triosocarbonate 4. Okay, H2CO3. Another one can be metallic hydrogen triosocarbonate 4, metallic hydrogen triosocarbonate 4. For example, sodium NaHCO3, NaHCO3. Okay, maybe KHCO3. Okay, all these ones are exception to organic compounds that are, or all these ones are carbon compounds that are not organic compounds. The presence of carbon shows that they are carbon compounds, but they are not organic compounds. So what did I say? Carbon monoxide, carbon dioxide, uh, uh, metallic, this is a metal, metallic triosocarbonate 4. Okay, hydrogen triosocarbonate 4, or you just say triosocarbonate 4 acid. You know, the presence of hydrogen shows that it's an acid. Then another one is a metallic hydrogen triosocarbonate 4. So these are exceptions to organic compounds. Okay, so let's keep moving. So in other words, organic chemistry is the study of carbon compound with exception of these mentioned above. Okay. However, the presence of numerous organic compounds can be attributed to the following properties of compound. You know that organic compounds are numerous. We cannot count them. They are so many. In fact, they are bigger than the inorganic compounds. And the reason is because of some properties. Okay. Let me show you the properties that makes organic compound numerous. Some properties that makes organic compounds numerous. Okay, okay. The first property that makes them numerous is that carbon atoms has the exceptional ability to carbonate. That is, they form carbon to carbon chain. Okay, and this carbon to carbon chain, you can form as many as you can. So that is one of the reasons that makes it what? Numerous. Okay, they can form, they can carbonate, and carbonation is simply the ability for carbon to combine with itself, forming straight chains, branch chains, or ring carbon. Okay, they can form straight chain like this moving to eternity, or branch chains like this where you have a branch, something like this, okay, or maybe a ring. They can form a ring. They can form a ring. We have dash, leave one, dash, leave one, dash. So they can form a ring. So this one is a branch. This is branch. This is branched chain. This is straight line chain. Why this is ring chain. Okay, so that is one of the properties of carbon that makes it numerous. Another property is that the ability of carbon compound to form isomers, that is different arrangement of the same carbon atom. Like this particular carbon atom can be arranged in different forms, so that is what makes them numerous. So one particular carbon compound can be arranged in different forms. That is what makes them numerous. Okay, that is number two. Then number three is that okay, carbon has the ability to form single bond, double bond, and triple bond. You know, this one is a single bond. Then for double bond, this one is a single bond when you just have single line. But for double bond, you can have two like this. While for triple bond, you can have three like this. Okay, so that is one of another reason that makes them numerous. And the last one is that the ability of carbon to freely combine with what? Oxygen, hydrogen, iodine, and nitrogen. Then all the halogens. Okay, the ability of carbon to combine freely with all the halogens. These are another reason that make them numerous. Okay, so now let's talk about the properties or the characteristics of organic compounds. The properties or the characteristics of organic compounds. Characteristics. Characteristics of organic compounds. Number one said that most organic compounds are inflammable and burn exothermically in abundant supply of air to yield carbon dioxide and water. Due to this reason, organic solvents are not heated directly. They are usually heated over water beds. Okay, so what does it mean? That like organic compound, the one of their properties is that once you put fire, they catch fire immediately. Okay, they catch fire immediately. They are inflammable. They catch fire immediately. That is one property of an organic compound. The next one is that organic compounds are all reactive, and that is why in every reaction of an organic compound we put something that is called a catalyst to fasten the reaction. Okay, they take very slow in chemical reaction. They are very very slow in chemical reaction. So that is why we add what is called a catalyst. You know, a catalyst is a substance that fasten or reduces the rate of chemical reaction. In fact, that changes the rate of chemical reaction. So, but in organic chemistry, we always put in a catalyst that helps us to fasten the chemical reaction. Okay, that is number two. Number three is that majority of organic compounds are non-polar. Okay, this means that they do not consist of ions. Organic compounds do not consist of ions. They are mainly molecules, except compounds such as chlorine, which is electronegative, or those consisting of hydroxy group. Okay, the non-polar substance are held together by a weak van der Waals force. You know that organic compounds are covalent. They take covalent bonding. Okay, covalent bonding. They don't undergo ionic bonding. There is no an ion there. For that reason, it makes their bond very weak. Okay, the force between them, the force that is holding them, is a weak force called a van der Waals force. Okay, so they are not metallic in nature. In fact, that reason itself shows that they cannot conduct electricity. Yes, for the reason that um they are not polar. They are not polar shows that what? They are non-electrolytic, which means they cannot conduct electricity. Okay, number four said that Organic compounds or organic solvents are insoluble in polar solvent like water, but very soluble in non-polar solvents like benzene and ether. Okay. Note that organic solvents having hydroxy group which consists hydrogen bond result to the solubility of such compound with water. Example of such compound are glucose and ethanol. For organic compound, the only compounds that can dissolve in water are just hydroxy group. Anyone that is in hydroxy group, the one that has OH, okay, because of the presence of oxygen and hydrogen, they can now dissolve in water. They can now react with water. So an example of such compound is what? Glucose and ethanol. I hope you know what is ethanol, the kai kai that you know in Igbo land. They call it kai kai. Okay, that's alcohol. It is called ethanol. Okay, yeah, they can dissolve in water. You can mix them with water, and then the glucose, can be mixed with water as well, because they contain what? Hydroxy group in them. Okay, now an example of a normal organic compound that cannot dissolve in water. For example, oil is an organic compound because oil is fat, is produced from fat. It's an organic compound and they cannot dissolve in water. If you pour oil inside water, it will float. Why? Because they cannot dissolve in water, but they can dissolve in kerosene. Pour oil inside kerosene, they will mix. Okay, yes, that is that. So number 5 said that they are mainly covalent in nature. Yes, like I told you that their bond is what? A covalent bond. And the solubility of organic compound is due to the strong carbon to carbon bond. The covalency in them makes them a non-conductor of electricity. Like I said before, that they cannot conduct electricity because there is no presence of ion. If there's no presence of ion, they cannot conduct electricity. Okay. Number 6 say that they generally have low boiling point. Okay, low boiling and melting point when compared to inorganic chemistry or inorganic compounds, due to the fact that they are non-electrostatic due to the fact that there is a non-electrostatic attraction between them. Because of the force, I told that the force that is holding the compounds are too tiny and they are called van der Waals force. That is why their melting points are very small. Any small thing they will just melt, and their boiling point very small. Any small thing they will just boil. Okay. uh, uh, so their melting point and their point are very small compared to inorganic compound. Inorganic compound, they are held together by a very strong force. So before they boil or they melt, it requires a high temperature. Okay, so you have to take note that the as the carbon increases, the boiling point and the melting point increases as well. Then the last one said that most organic compounds are unstable to heat and decomposes into smaller molecule on heating above 500 degrees Celsius. Please, you must note that they melt above 500 degrees Celsius. Okay, so now let's talk about the terms used in organic chemistry. I have given you the properties of them. Okay, you can go through them again. I said that number 1 property is that what? That most organic compounds are inflammable, that they easily catch fire. That is number 1. And number 2 is that what? They are unreactive. They are very slow in their reaction. That is why we always apply a catalyst. Okay. Number 3, I said that what? They are being held by a very weak van der Waals force. Okay, so they are non-polar. For that reason, the bond is called the covalent bond, and because the covalent bond, it now makes them to so it now reduces their boiling and their melting point. Okay, so they melt easily, they boil easily. And note that as the carbon increases, the boiling and the melting point increases. And for the fact that there is no ionic bond between them, they don't conduct electricity. So this is the summary of and then note that they melt or boil at what? 500 degrees Celsius, above 500 degrees Celsius temperature. Okay, that is that. So now let's talk about the terms used in organic chemistry. The terms used in organic chemistry. Number 1 that we'll talk about is hybridization. hybridization of carbon atom. The second one we'll look at is homologous series. The third one we'll look at is the okay. The third one we'll look at is the general formula. The fourth one we look at is the alkyl group. Alkyl group. The fifth one we'll look at is the functional group. The sixth one we look at is the formula. The formulas we know, and the formulas we know that we look at under that, the first one we look at is the empirical formula. Empirical formula. The second one we look at is the molecular formula. And the third one we look at here is the structural formula. Okay, that is number 6 now. Number 7 that we'll look at is isomerism. Then the final one, number 8, that we'll look at is polymerization. Okay, so these are the terms used in organic chemistry that we'll look into. So let's start from the first one, hybridization. SPDF. You should know that in your inorganic chemistry. So if you don't know about SPDF, please, you can go to our video on that. Okay. Now, the first one we want to talk about is hybridization. They said hybridization is the mixing of two or more orbitals of the same principal quantum number to give new sets of orbitals which are exactly equivalent. The new sets of orbital are hybrid orbitals. Hybridization can be sp3, sp2, and sp. Okay, sp3, sp2, and sp. So let's take the first one, sp3 hybridization. Now, in sp3 hybridization is simply when one s orbital, I see one s orbital and three p orbitals. Are you getting that? One s orbital hybridizes with three p orbitals of carbon atom. Then sp3 hybridization is formed when one s orbital and three p orbitals, okay, hybridizes. Then you now get what? sp3 hybridization. And they say after spreading out, the unpaired orbital are aligned at 109 degrees. Please, very very important. The unpaired electrons are what? Are aligned at 109 degrees away from each other. Okay, so the angle between the unpaired electrons for sp3 is 108. Okay, you should know that we just have 108, 109, 120, and 180. So for sp3, the angle between the unpaired electron is 109 degrees, but for sp2 is 120 degrees, and for sp is 180 degrees. It's an exam question. Please take note of that. Okay, the overlap of each hybrid orbital with the orbital of the hydrogen atom and chlorine atom results in the methyl and tetrachlorine methyl, which are tetrahydride in shape. Okay, so let's talk about the shape. We have the s orbital. Let's have the s orbital as this, and then let's draw our the p orbitals. The first one, I know the p orbital is like a dumbbell, like this. Okay, let me call this py. Another one can come here. Okay. Px. I did not draw it very well. Px. Then the last one can be pz. Let me make the last one here. Pz. Okay. And the angle between the py and pz, the unpaired electron, is 109 degrees. Okay, you need to know that. That is when they hybridize. Okay, so if this passes through hybridization, I have that this is the dumbbell, um the dumbbell, this one, and is 109.28 degrees. Okay, this is hybridization. Okay, so that is that. So the only thing you need to know for me is that for sp3 hybridization is simply one orbital. When one s orbital hybridizes with 3p orbitals, okay, then it forms sp3 hybridization, and the angle between the unpaired electron is what? 109 degrees. Please take note of that. Okay, now for sp2 is the same thing. That is when one s orbital hybridizes with what? 2p orbitals. Then what is formed? Then sp2 orbitals is formed, and the angle between the unpaired electron is what? Is what? 120 degrees. This one is for 109 degrees. This one is 120 degrees. This one is what? 180 degrees. Okay, so for sp hybridization said this involves the mixing or blending of one s orbital and one p orbital to produce a hybrid orbital directed along a straight line. This one moves along a straight line, therefore making an angle. Angle on a straight line is 180, so making an angle 180 degrees. Okay, making an angle 180 degrees. So that is that. Now let's talk about number 2, homologous series. Okay, for homologous series, this is the family of organic compound which follows a regular structural pattern in which each successive member differs by CH2. Very, very simple. Now to get the next member is simply just add one carbon and two hydrogen. Very simple. For example, alkane. I want to give you an example. Alkane, formula for alkane is CnH2n plus 2. I hope you know. So which means um the first member is what? Methane. And methane is when n is 1. So methane, for methane, is what? C1 C1H, 2 times 1 2 plus this 4, C1H4. This is the first member. Now to get the second member is when n is 2. If n is 2, you have what? C2H, 2 times 2 4, 4 plus 2 6. You will see that the difference between these two members is simply by adding, just add 1C to this one and add 2H to this one. So alkane is a member of the homologous series. Are you getting that? So whenever you want to get the next member, in fact, to get the next member here, if I don't want to use this formula, it's simply for me to add 1C here to get C3 and add 2H here to get what? H8. As simple as that. Okay, so a homologous series is just a member or a family of organic compound which follows a regular pattern. The pattern is follows that for me to get the next person is just for me to add 1C and 1 carbon and 2 hydrogen. That is CH2. As simple as that. Or you say that you're adding what? 14 gram. How did I get the 14 gram? By the molar mass. That is what? Carbon is what? 12 plus hydrogen is 2. 2 into 1. That is 12 plus 2, which is what? 14 gram. Okay, that is the mass. The mass, you know that mass is equal to what? Mole times what? The molar mass. And the mole is what? Is just 1. So 1 times the molar mass, what? 14 gram per mole. So which will give me that what? 14 gram. So to get the next member is simply by adding what? 14 gram, or by adding what? CH2. As simple as that. Okay, or the methyl group, or the methyl group. So that is that. Okay, now characteristics of homologous series. I hope you have known what a homologous series is. A homologous series is simply a family of organic chemistry where to get the next person, to get the next member, is simply by the previous member you add what? CH2 to it. Okay, characteristics of a homologous series. Number one, all members of the same homologous series share a general formula. They share a general formula. Like I said before, for alkane, the formula for alkane is what? CnH2n plus 2. Okay, but for alkene is simply removing two hydrogen to have what? CnH2n. Then for alkyne, remove another two hydrogen, have what? CnH2n minus 2. So these are the formula they follow. They have a particular formula, general formula they follow for every homologous series. Okay. So the next one, I didn't tell you examples of a homologous series. Some members of homologous series are the alkane, the alkene, the alkyne, the alkanol, the alkanoic acid, the halogen alkane, the amino alkanes, the alkanones, and alkanal. I'm going to give you a summary, a table that summarize all these things I'm saying. Okay, we have gotten number one property, or number one character of a homologous series. They have a general formula. Each of the family has a general formula. The family of alkane, this is their general formula. The family of alkane, this is their general formula. The family of alkyne, this is their general formula. So from their general formula, you can now get all their members, Okay, so that is that. So the next one is number two, which is what? Each successive member differs by the addition of CH2. Okay, like I told you before, to get the next person is simply by adding CH2. Then you know that that family is a member of the homologous series. Okay, number three said that the members of the same series have the same chemical properties. Yes, the members of the homologous series have the same chemical properties. For the alkane, all the families of alkane have the same chemical properties. Okay, and so on. And the next one is that they are being prepared by the same laboratory preparation. Yes, they are being prepared by the same laboratory preparation. Then the next one says that they are slightly different in their physical property. They are slightly different in their physical property. Okay, the physical properties of the members changes as the number of the carbon changes per molecule. Okay, so like I told you before, in organic compound, normally as the carbon increases, the melting and the boiling point increases. The same thing in homologous series. You know that melting and boiling point are physical properties, and they told that the physical properties changes as they increase in their number of carbons. Okay, and is a slight change anyways. Okay, example, they say that the melting and boiling point of an alkane increases by the solubility, but the solubility decreases. Okay, the melting and the boiling point increases. Please note that the melting and boiling point increases, but the solubility decreases. So in their solubility, for them to be soluble in water, the more you are adding carbon, the more it is very difficult for them to dissolve. Okay, yes, their solubility, is it difficult? Their solubility increases. Yes, solubility decrease. Yeah, the solubility decreases. So that is, it is more difficult to be soluble in water. Okay, so that is that for homologous series. So the next one we'll talk about is the the general formula. The general formula. Number what? Number four. So number three, the general formula. Okay. Now, for the general formula, you need to know the general formula of all the homologous series. I'm going to give a table on that. Okay, you need to take time and then know it by yourself. But during the table, I'll be explaining them. for you, but we have to solve some calculations involving those general formulas. Okay, so let's solve some calculation. Question number one. Question number one said determine the general formula. Let me call it GF. Okay, the general formula of an alkane with 9 carbons. Okay, solution. We need to know that the general formula for alkane normally is what? CnH2n plus 2. Please, you need to know that. And they say that what? That Cn, the number of carbon is what? 9 carbons. So if C cancels C, automatically we have that N is equal to what? 9. So if N is equal to 9, the general formula becomes C9H2 into 9 plus 2. So what do we have now? We now have C9H20. Okay, C9H20. So that is the first question. The second question said determine the general formula, or the formula, not the general formula. Determine the formula. It's not a general formula, please. This is a formula of this particular one. This is only formula. Why this one is the general formula for alkane? Okay, so determine the formula. So determine the formula of an alkane with 30 hydrogens. Okay, very simple. Solution. What do? We know the general formula for alkanes. The general formula for what? Alkanes. The same formula, which is what? CnH2n plus 2. Okay, notice the way I'm writing my own plus 2. My own plus 2 is down with 2n. Okay, and they say that what? That the number of hydrogen, which is H2n plus 2, is equal to H30, because the hydrogen there is 30. So if H cancel H, what do you have? That 2n plus 2 is equal to 30. So what do we have now? 2n is equal to what? 30 minus 2. So what do we have now? 2n is equal to 28. So therefore my n is what? 28 divided by 2, which is what? 14. So if we have gotten n to be 14, then the formula becomes C14H. Here must be the same 30. If you like, you check it. 2 times 14 is 28 plus 2, 30. Okay, C14H30 is the answer. Okay, question number 3. Question number 3 said determine the formula of alkyne. Determine the formula of alkyne, okay, with 8 carbons. Very simple. Solution. We know that the general formula for alkynes are what? CnH2n minus 2, because alkane is CnH2n plus 2. Alkane is remove 2 here, it will now be CnH2n. Why alkyne remove another 2n? That is why you have minus another 2n. Okay, but they say that the number of carbon is 8 carbons. So if this cancel this, I'm going to get that what? My n is equal to 8. So the formula becomes what? C8H 2 times 8 is 16. 16 minus 2 is what? 14. So I have what? C8H14. Okay, question number 4. Question number 4 said determine Determine the formula of an alkyne with 34 hydrogens. The same thing. Okay, so what do? The general formula for alkyne, the general formula for alkyne is what? CnH2n minus 2. So what do? They say that the number of hydrogen, that is H2n minus 2, is equal to what? 34 hydrogens. So if H cancel H, we now have that 2n minus 2 is equal to 34. So therefore 2n is equal to 34 plus 2. So 2n is equal to what? 36. So n is what? 36 divided by 2, which is what? 18. So the formula, if you have gotten n, the formula becomes what? C18H. The H must be the same thing. H what? 34. Or you check it. 2 times 18 is 36. 36 minus 2 is 34. So that is the formula. Question number 5. Question number 5 said, determine okay. Question number 5, determine the formula of alkene. Determine the formula of alkene with 7 carbons. Okay, solution, very simple. We know that the general formula for what? For alkene is equal to what? CnH2n. So they say that the number of carbon is just 7 carbons. So if C cancels C, therefore my n is equal to 7. So the formula becomes what? C7H, 2 times 7, 14. C7H14. Okay, so question number 6. Question number 6 said, determine the formula of alkene with number 6. Formula of alkene with 20 hydrogens. 20 hydrogens. Okay, solution, very simple. The general formula for what? For alkene is what? CnH2n. So they said that what? That the number of hydrogen is what? 20 hydrogens. So H20. So if H cancel H, we know that what? 2n is equal to 20. Therefore, n is what? 20 divided by 2, which is what? 10. So the formula becomes what? C10H20. Okay? You see that this is very simple. Question number what now? Question number 7. Question number 7 said, they said if the molar mass of an alkane is 72 gram per mole, okay, they say find the molecular formula. Okay, solution, and this is very, very simple. They gave us the molar mass of alkane, but we know that the general formula for alkane is what? CnH2n plus 2. Is it not true? Now, what does it mean? How do you get molecular formula? We say that what? N, the carbon is what? 2. N of carbon, sorry, the carbon is n of carbon plus what? 2n plus 2 of hydrogen, okay, is equal to what? That 72 they gave us. So clear the bracket. This time, this. In fact, carbon is 12. The molar mass of carbon is what? Is 12. So what do I have? N in bracket of 12 plus 2n plus 2 in bracket of 1 is equal to what? 72. So what do we have? 12n plus 2n plus 2, because 1 times this is 2n, 1 times 2 is 2, is equal to what? 72. Permit me to finish it up here. So what do we have now? We now have that this plus this will give you 14n. 14n is equal to what? 72 minus 2. So 14n is equal to what? 70. So n is equal to what? 70 divided by 14, which is equal to what? 5. So since you have gotten that n is 5, just put it here. Therefore, the formula equals what? C5H 2 times 5, 10. 10 plus 2, 12. So C5H12 is the answer. Okay? So the next one, question number 8. Question number 8 said, 0.5 mole, 0.5 mole of monohydric alkanol, okay, weighs 44 gram, find the formula. Solution. Okay, they gave us the number of mole. Okay, we have that the mole is equal to what? 0.5 moles. We need the molar mass. Okay, we know that the mass is equal to what? 44 gram. And we know that mole is equal to what? Mass over what? Molar mass. Don't forget. So if we have the molar mass will just be what? The mass divided by the mole. Okay, which is what? 44 divided by what? 0.5, which will give you what? 88 gram per mole. We have gotten the molar mass. Okay, so once you have the molar mass, then get the general formula. The general formula of monohydric alkanol, okay, is what? Can we remember the formula? That is ROH. Yes, this is ROH. I think, if I can remember, yes, ROH. So what is my R? Don't forget that R is methyl. Methyl is CnH2n plus 1. Yes, CnH2n plus 1. Then put your OH. Okay, so let us get it now. So what do I have? I have that N of C, the way we did the other one, plus 2n plus 1 of H. Okay, then plus O, then plus H. And all these things is equal to what? The molar mass of that compound, which is 88. So what do we have now? C is 12. So I have 12n. 12 times this, 12n. H is 1. 1 times this will give you what? 2n. 1 times 1 will give you what? 1. Plus oxygen is 16, while hydrogen is 1, and is equal to 88. So what do we have? 14n plus 18 is equal to what? 88. So 14n is equal to what? 88 minus 18. So 14n is equal to what? 70. So my n is equal to what? 70 divided by 14, which is equal to what? 5. So if it's equal to 5, then the formula, n is the only problem we are looking for. So the formula becomes what? Put it here. C5H 2 times 5, 10 plus 1, 11. H11. Then put your OH. So that is that. So I think I'm going to stop here. So thank you very much for watching. In our next video, we will now talk about the next one. And the next one is the alkyl group. That's the next one. Let me check my time. So thank you very much for watching. Please subscribe and share to everyone that needs it. Bye bye.